it?
Yes.
Okay, so basically, so the degree is 4 because it's the first, no, the first like,
The highest power.
but like also, there's 4 of them, so it's 1, 2, 3, 4 because this is just 1. So the leading coefficient's 1 because you don't have a number coefficient right there, so it's 1.
Yes.
So then you have, it's infinity because it's positive and even. Its number of roots is 4, and then but you just subtract, and so its number of turning points is 3.
Okay.
And then so the factor intercept form. So basically the common factor here is x. So you take out the x, so it'd be x to the cubed minus 4x squared minus 4x plus 16. And so you would take out the x squared. So you group them together first. So you take this away for now, but you group them together. And so the common factor between that is x squared and x minus 4. And then the common factor here for this one is 4. So it would be x minus 4. So you have the same factors, so you know it's correct. And so then you take these two, and so it would be x squared minus 4 and then x minus 4. But you still have this x, but then this is squared. So then you have to make it 2. So 4 divided by 2 is 2. So it's x minus 2 and x plus 2 and then x minus 4 because it's a negative 4, which means it has to have a positive and negative. So then you do this over here. And then you also add the x in your final because you took it out. So it would be x equals 0 because this is 0. X equals 2 because this is 2 when you equal it to 0. Then it would be x minus 2 because it's negative 2. And then x equals 4 because it's 4. And then they pass through because they have all the multiplicity of 1. So it's going to pass through all of them.
Okay, very good. Let's give a round of applause to Ivy. Okay. Now, so I just want to highlight, okay, so when you are going to determine the degree, you just have to look at the highest power, okay? The number of terms, it's just a coincidence that the number of terms is also 4. But we're not going to use the number of terms for the degree, just the highest power, okay? What else? You have a question? All right, what else is not, like, what else do you have, right? Questions do you have here? Any questions? Now, I was able to see a work here wherein they group it directly, and then they come up with x cubed minus 4x, right? You can, yeah, you can. You can have that x cubed minus 4x, but then you can factor x cubed minus 4x, right? You can take out the x, so that's x times x squared minus 4, and then just like what Ivy said, you can factor x squared minus 4 as x minus 2x plus 2. By the way, when you factor the difference of two squares, you do not divide by 2, but you take the square root of the constant, okay? Because sometimes, let's say this is 9, and 9 is a perfect square, but you don't divide 9 by 2, but you take the square root of 9, okay? Just want to put that there. Any questions?
So also is leading coefficient and A the same thing?
The same thing, yes. Yeah. So if you're asked to solve for A, that means you're asked to solve for the leading coefficient of this polynomial function. What else? Okay, all right. So now we're going to proceed with our notes today. So the notes basically on the graphing, just to understand the graph and the features of the graph of your polynomial functions.
Please dismiss students in Russ and Grant's homeroom to the Drumhead hallways for pictures. Mr. Russ and Mr. Grant. Thank you.
So, will you be here at 11? No. Because that's they're gonna call the rest that we're not able to do the pictures during the scheduled time. It will be at 11 to 12. So if you'll be around at that time, you don't have to go with her. Okay, so you can go. Just tell them that you will not be here, yes, during that time. Yes. Okay. All right, so it's just graph, right? We're just going to complete the table and then just graph this here. All right. So here, you're given a polynomial function in the intercept form or factored form, right? Okay. So how do we determine that a value, the leading coefficient of this? What is the a value? 1. Okay. So that's 1. Again, the polynomial is f of x equals x plus 1 times x minus 2 times x minus 4. What is the overall degree? 3. Okay. Again, if the polynomial is written in the factored form, you have to sum up the powers or the exponents. So 1 plus 1 plus 1. So the total is 3. Okay, so we got odd positive. So what's going to be the end behavior?
It's going to be negative infinity.
Yes. Think of that as increasing, yes. So negative infinity, infinity. Okay, but we don't have an x here. Let me just write the x for our notation. So x approaches to negative infinity. That means we're looking at the left side. And then x approaches to positive infinity. We're looking at the right side of the graph. And then our concern is what happens to your y values, right? So according to Ivy, this one goes down, so negative infinity. And then the right side goes up or rises, so positive infinity. Okay. Now, what are the zeros and multiplicities? So it's easier to find the zeros because you already have the factored form. Now, can you tell me one of the zeros?
The zeros is x equals
Negative 1. And then?
negative 1, and then the multiplicity of that would be 1.
Yes. And then let's just write all the zeros because all of them has a multiplicity of 1. So x equals 2 and x equals 4. Yes. Right. So all of them has multiplicity of 1. And then what happens at the zeros? Pass through, right? Okay. So we can just write pass through all zeros. Now, for the y-intercept, we know that we have a y-intercept when the x value is 0. So we can just plug in when x is 0, then plug in 0 to the variable x to solve for y, right? So I can write this as y equals 0 plus 1, 0 minus 2, 0 minus 4. And then just simplify. So that's 1 times negative 2 times negative 4, which is equal to positive 8. Okay? I just plug in 0 to the x, right, to solve for my y. So when x is 0, y is 8. Therefore, the y-intercept is 0, comma 8. Okay? Now, for this part, for the local max, starting from the local max up to this, we need to have our graph, right? So this part we're going to graph. We're just going to estimate the graph. But think of this. Yeah.
0 minus 2, that's negative
2.
2.
Yes.
How is it positive 8?
Because we have a negative 4.
So
We're multiplying now.
oh, we're
Yes. Multiplication, right? Because the factors, basically the factors, is like same thing as like you're multiplying the factors, right? So the parentheses means multiplication. Okay? Any other question? Okay, so again, just think of this local max and local min or minimum as your turning points.
Still, I can't like envision it without putting the decimal.
Yeah, that's why we're gonna look at the graph, right? Okay. Here.
Oh, so we can have this.
We can have the graph from this part. Okay.
Wait, so get out your computer.
Okay, so this is how the graph look like, right? So we're just gonna find the turning point. So this is your local max, this is your local min, and then we're just gonna write 3 decimal place. Okay, is this the correct function, right? Plus 1, minus 2, minus 4. Okay, can you write this down?
Could I get out my own computer and write it? Because I
Yes.
can't really see that.
Yes. Yes, you can take out your Chromebook and go to desmos.com and then just graph our polynomial function. And then so that you can, if you cannot see this right here. Okay, 0.214 and then 8.201. that's going to be your local max. So think of these as your turning points, right? So the turning point at the top is your local max. The turning point at the bottom is your local min. So this is your 3.12 if you're going to round up, and then negative 4.061. Yeah, write it down. Oh, for the local max, again, that's 0.214, comma, 8.209. And then for the local min, that's 3.12, because we're going to round up, and negative 4.061. Okay? All right.
So when you're on Desmos, can't you just look at
Yes.
the wait? Can't you just look at the y-intercept?
Yes. But since here you're gonna show the work for the y-intercept. Okay? Yes, but you can check. The y-intercept will be 0.8 there.
I don't understand how you got the y-intercept without.
The what? Again, to solve for the y-intercept without the graph, okay, we know that the x value of the y-intercept is 0, right? So you plug in 0 to your variable x. After you plug in, just simplify and then multiply all the numbers, okay? All right, so what we're going to do here is we're going to try to plot all these points so that we can estimate the graph here. It doesn't have to be exact, okay? We're just estimating because we're going to use that for the interval of increase and decrease, okay? So first is we're going to plot our x-intercepts, which are the zeros, right? So we have negative 1, it's right here, and then positive 2 is right here, and then 4 is right here. And also we know that the y-intercept is 0.8, so that's going to be right here. And also we know that the local max is 0.214, 8.209. So let's just estimate somewhere here. And then local min, which is the turning point at the bottom, you got 3.12 and negative 4.061. 3.12, negative 4.061. So just estimate that right here. Okay. Now, so what we do is we're doing this so that we know and understand the concept of end behavior, right? Because if this is the end behavior, that means at the left side of the graph, we're going to start from the bottom because that goes down. It falls to the negative infinity. So if we're going to connect the points, we have to start from the bottom, okay? And then pass through, because the behavior at x equals negative 1 is pass through as well as x equals 2. So we're going to pass through that. And then we're going to go to the, of course, to the y-intercept. And then go to your max, local max. Once you hit the maximum, that's the time you're going to change the direction of the graph, right? It's going to go back down. And then, so when you go down, you go to the x-intercept and then pass through, right? So pass through that, pass through 2. And once you hit the local minimum, then you're going to change the direction. You're going to go back up. And then you're going to hit the last 0, which is 4. And then also it's passing through. And we don't have any more points here. And we know that at the right side, the graph goes up. It rises because of the end behavior, right? Okay, so this one falls and this one rises. So that's the estimate of our graph. Okay, and we're using the end behavior and we're using the behavior at the zeros to graft it manually. Okay? Now, okay, so from there, we can identify the interval of increase and decrease, right? How many increasing parts do we have? We have 2 increasing parts. So I can shade this part to this is increasing up to the local max, right? So how do we write this in the interval notation? As negative infinity, comma, So this point, which is the x, by the way, the increase and decrease, we're only writing the x values. All right. So if we know that this is your local max and the x value of the local max is 0.214, so that's negative infinity comma 0.214. And then union, because we have two of them. And then this is the second increasing to here, and then that goes to the positive infinity to the right. And we know that this is your local minimum, and the x value of the local minimum is 0.312. So that's 3.12 comma infinity.
Please dismiss students in Grace and Frost homeroom, the driver's ed hallway. For pictures, Grace and Frost.
Grace and Frost. All right, interval of decrease. Can you give me the interval of decrease? We only have how many intervals of decrease?
1.
We only have one, yes. So this middle part is the decreasing part, right? So, yes. 0.214, yes, that's correct. Christian, comma. What's the x value of the minimum? 3.12. Uh-huh. Okay, so that's the interval of decrease. Now, what's the domain of this?
Negative infinity, positive
Yes.
infinity for both.
For both. Domain and range, yes. Because farthest left, farthest right, there's an arrow. Top and bottom, there's an arrow. Although we have a minimum and maximum here, but this side will go down infinitely, this side will go up infinitely. Okay, so that's our graph, and that's the feature. Now, we'll do number 2 and 3, and then I will let you do number 4 for your practice, okay? Any question?
Yeah, actually, well, never mind.
All right, let's do number 2.
Sorry.
So we have g of x equals negative of x plus 3 times x plus 2 times x minus 1 cubed. What is your a value? Negative 1, yeah. And what is our overall degree? 5. So we got odd negative, right? So what is the behavior of odd negative again? Decreasing, yes. Positive, negative. That's right. Okay, so I'm just going to write these notations for the x, okay? And then we're looking at what happens to your graph for the y values, right? So here it goes up, so it rises, it goes to positive infinity. Then at the right side it goes down, or it falls, so it goes to the negative infinity. Okay, now what are the zeros and multiplicities? We got these three, so we got x equals negative 3, x equals negative 2, negative 2. And both of this has a multiplicity of 1. Okay. And then what about this? This is
That's a multiplicity of
3. Yeah. X equals 1 with a multiplicity of 3. Just the powers. Yes, just the power of each factors. Yes. And then so what happens at this zeros? So it's multiplicity of 1, that means it's passed through. This one is multiplicity of 3, that means that curves, right? So this one is passed through at x equals negative 3 comma 2. And then this one is curve at x equals 1.
Would it be negative 2?
Oh, sorry. Yeah, negative 2. Thank you. All right. And then how do we solve for the y-intercept? This is when the x value is 0. So when x is 0. So we're going to plug in 0 back to the function. So plug in 0 to your x. Then this will be y equals negative 0 plus 3, 0 plus 2, and then 0 minus 1 cubed. And then so that's negative. 0 plus 3 is 3. I'm just simplifying. 0 plus 2 is 2. And then 0 minus 1 is negative 1. If you raise negative 1 to the power of 3, it's also negative 1. Okay, so if you multiply this, negative 3 times 2 is negative 6, times negative 1 is positive 6. So therefore, the y-intercept is 0, 6. Okay, then from this part, we're going to look at the graph. We can solve this using the calculus idea if we're not going to use the graph, but for now in
We
math
don't worry
3,
about the X.
what, for the local max?
So for the y-intercepts,
Yeah.
like the exponent on the 0 minus 1, we do take that into account. We
Yes.
just get -1 because
Because
-1 to the power of 3 is.
it's -1. Yes. Yes. So make sure you consider the exponent. Yes, you're going to take that into account because you're simplifying this. Right? But -1 to the power of 3 is also -1. Also, if you have a coefficient, or if you have a leading coefficient in front, you're going to use that when you multiply or simplify this to find the y-intercept. Okay, so let's look at the graph now. And then, so we have the graph here. Okay, as you can see, the graph curve somewhere. It's right here. And we just have to know, so that we can graph this here. So we should know this local minimum and local maximum.
The local max is.
-116. Yes.
I don't. Wait. It would.
-116. Make sure you have the correct function, okay? Correct function. Check your function, Ivy.
Yeah, it's negative x plus 3, x plus 2, and x minus 1.
Cube?
Cubed? Oh, sorry.
Yes, there should be a power of 3. Okay, so right here, local max is -1 comma 16. And then the local min is yes, I have my steps today. But all right, so here, can you copy this? Did you write it down? Okay.
Wait, no, I didn't.
It's okay. I'm gonna write it down here. I'm gonna use this local min -2.6
Wait,
and -11.12. Okay, question on the max and minimum?
Yeah, how'd you get point 12?
Is it not point 12?
It's negative 11.197.
you round up.
You round up.
Yeah, but the 9 would become.
Oh yeah. Okay. It's okay. So it's just a round off mistake. So 2, 0. Not 1, 2. Yeah. 5 on a degree. Yes, because we're given a polynomial as a factored form. So if it's in factored form, we're going to sum up the exponents.
Yeah, but how is it 5?
Because you have 1 plus 1 plus 3.
Well, why don't you use the other x?
Where's the other x?
In the third one.
Oh, this one?
Yeah.
Oh, okay. That one is just this entire factor is raised to 3.
Oh.
Yes. So this one is just raised to 1. So, I mean, you're just going to count it as 3, not 4. Okay? Yeah. Any other questions? Okay. All right, let's graph. All right, so let's plot the points. We have what? -3. Make sure you have the graphs there. Okay, -3, -2, and then 1. And then what else? We have the y-intercept, 0, 6. Okay? And we just need the local max and minimum. So -116 is your -116. It's beyond our graph. So we just estimate that this is going to be around here. Okay? And then -2.6, 2.6, and then -11.20. So let's just estimate that around here. Okay? All right, now, we know that the end behavior, we start from the top, right? Because it rises. So from the first x-intercept, we're going to start from the top. Make sense? Okay, I'm just going to... Right, so we're going to start from the top. And then it's going to pass through the first x-intercept, the first 0, from the left. And it's going to go down all the way to the minimum. Okay? This is an arrow from the top. Then goes pass through the x-intercept and goes to the minimum. And then you're going to, once you hit the minimum, you're going to go back up and then pass through, right? The behavior of the second 0 is pass through -2. So pass through -2, and then you go all the way to the maximum, the local max. And once you hit the local max, you're going to go back down. So you're going to go to the next x-intercept, but then you have to pass through also the...
Please dismiss students in Rector and Holloman's homeroom to the driver's ed hallway for pictures. Rector and Holloman. Thank you.
All right, so we're going to hit the y-intercept, and then this one not pass through, by the way. The last one is curve. So how do we curve? Yeah, so just draw like this, like that. It's going to curve at this point, okay? So the bounce is going to go up, right? But then it's just curved, so it's going to go all the way down. And we know that it's going to be -infinity at the right side, right? That's the end behavior, okay? So the end behavior is going to give you the idea on what will happen at both ends, okay? So that's going to be what the graph look like, right? Estimate. Okay, so interval of increase. So we have one increasing interval, right? So from here up to here, that's increasing. So how do we write that? What is this? The x value of the minimum is -2.6, so -2.6, comma. And then the x value of the max is -1, so comma -1. And that's it for the interval of increase. And then for the decrease, we're going to think of this as decrease in this part, right? Because although it's curved, but then it's going to go down all the way. So therefore, we have two decreasing intervals, okay? So we got -infinity, comma, what is the minimum of this? -2.6. And since we have two, we're going to put union, okay, union. What's the x value of the max? That's -1. And then, although it's going down, it's going to the right. We're only writing the x values, so it's going to go to +infinity. Okay? Now, what is the domain of this? Okay, -infinity to +infinity. But what is the range? The range is also, yes, all real numbers, because although we have a max here, but then this arrow will go up infinitely. Okay? So it's also going to be all real numbers. Yeah. Decrease. So we got two decreasing parts. Let me just shade this part. So this part is decreasing. So we're only writing the x values, right? So from the left, there is an arrow. So that's why it's -infinity up to this point. This is the minimum point, right? And what is the x value of the minimum? -2.6. So that's why we got -infinity to -2.6. That's the first decreasing. Does that make sense?
That
Okay.
makes sense.
So then we'll do the next one. Okay, so this one is where the graph starts to decrease. The x value of this, because that's your maximum, the x value of the max is -1. And then it goes down here. But then we're only writing the x values, it's also going to the right. So that's why it's -1 to +infinity, not -infinity. Okay?
But whenever you're like on the left side, like I don't know if this is stupid, but like since the arrow is like pointing upwards, wouldn't that mean it's like increasing?
Yes, but then again, we're only writing, let me just highlight this, because you're thinking about the y. You're thinking because it starts from the top, that means it's +infinity. Okay, this one are your x values, remember? These are your x values. So we're only reading the graph from left to right. It doesn't matter if it's from the top or the bottom. Okay? Any other questions? All right, last example. We got this. Okay. Now, what is the a value? It's 1. What is the overall degree? Okay, this is the one that I think Lily is confused earlier, because if you have an x here, you're gonna count this as 1 if you have it outside, because the exponent of x is 1, right? Yes. So this is gonna be 4, right? 1 plus 2 plus 1. Okay. Yes. So even positive. If this is even positive, what will be the behavior? Even positive, class. What's the behavior? Positive, positive, right? Think of that as like both sides goes up. Okay, so I'm just gonna write the x. Again, we're concerned about what happens to your y. Now both sides goes up, so both sides go to the positive infinity. All right, so for the zeros, can you tell me one of the zeros? This x is just on its own, so we can set it to 0, right? X equals 0. And then the other one that has a multiplicity of 3 is the -3. So x equals, I can write that first, because both of this has a multiplicity of 1. And then what's the last one? X equals -5. What is the multiplicity of this? 2. Okay. So now, what's the behavior? This one is pass through. Pass through x equals 0, comma, -3. And then bounce. So this is the one that says bounce because the multiplicity is even. Bounce at x equals -5. Okay. Now, what is the y-intercept? So again, this is when x equals 0. Now, so when x is 0, since we have an x here, 0 times everything is going to be 0. So therefore, the y-intercept is just at the origin, 0, 0, right? Or we can just just to show it, 0 times 0 plus 5 squared times 0 plus 3. So this 5 squared is 25 times 3. Then times 0 is going to be 0. Okay, so therefore the y-intercept is just at 0, 0, which is at the point of origin. And that can also be our x-intercept. Okay, all right, so local max. Local max, we're going to go here. Okay, now this graph doesn't go all the way down, right? Therefore, the range is not going to be -infinity to +infinity. Okay, we're going to do that later. But then your local max is going to be this. Okay, can you write this down? Okay, can you write this down, Asher? And then I'm going to copy yours. Okay, that one, that's your local max. And then your local minimum, because we just say local minimum, it doesn't have to be like the lowest turning point. As long as you have a turning point at the bottom, that can be considered as local. Okay, so therefore we have two local minimum. So this is your local max, and this one is your local minimum, -5, 0, and then this one is also considered as your local minimum.
Is there a union in between them?
No, we're not gonna put a union because we're not writing an interval. Only if it's interval we're gonna put a union because it's like connecting the two parts. But then if you have only a point, just put a comma. Right? Or you can put an and, the word and. Right? So this, comma, this. Okay?
So the local maximum
But when they're both positive infinity, when the y is both the in behavior, the local max would be
Groundskeeper and Akers home room to the driver's ed hallway. Groundskeeper and Akers. Thank you.
Oh, you wrote it. Okay. Yeah, I accidentally did it. What's the again? Local max. Just look at the graph where the graph turns, right? It's just a turning point. Negative 32. What's your question? You have a question? No.
Yeah, I was just kind of confused on the, like, about the y-intercept. Like, what did you plug in to, like, get your...
I plug in the 0 to the variable x in your function, yes. So because x is 0 when you have your y-intercept, right? So if you plug in 0 to all the variable x's, right? 0 times 0. And then if you multiply 0 to all of that, it's going to be 0.
Okay, so whenever you're finding the y-intercept, you just
Plug in 0, yes. Plug in 0 to the x. Hello, yes. Okay. All right. Julie, yeah, you have an early dismissal. Okay, and then we're just gonna plot the points. So what do we have here? We got 0, and then negative 3, and then what else? Negative 5 is right here. So 0, negative 3, and negative 5. And what is your y-intercept? It's just the 0, 0. And then local max. Local max is negative 3.75. So this is negative 3 right here, and then 4.3. There's something right here. And then local min. So negative 5, 0, which is also your minimum. Okay, we're gonna have that later. And then negative 1, negative 32. So all the way down here. So let's just assume that this is negative 32 here. Okay. So again, we're going to start from the top, right? We start from the top because both ends goes up. It rises. So we start from the top. Okay. And then because at negative 5, the graph bounces, right? At the 0. So once you hit the 0, you did not pass through, but you go back up because that's bounce, right? So from here, it bounces. So when it bounces, it goes back to the max, okay? Now, once it hit the max, you can go back down, but then the next one, the behavior is passed through at negative 3. So we pass through at negative 3, and then we go down back to the, or down to the local minimum. And once you hit the local minimum, then you go back up, and then you're going to pass through because it's going to be passing through 0. So pass through 0, and then right there. Yeah.
So say that there's for like, okay, so local max.
Mm-hmm.
I'm going to problem 4. I know we're like supposed to do that on early,
Yeah.
but like I'm looking at the graph,
Mm-hmm.
and it looks like it's like it goes up and then it goes down and then it goes back up. So there's 3 turning points.
Mm-hmm.
So would you say there's 2 local maxes, or is it just the higher one?
There are 2 local max.
Okay, so you would do union.
No, just put a comma.
Okay.
If it's an interval, put a union, but not for the points. Yes.
Thank you.
You're welcome. All right. So interval of increase. So how many increasing parts do we have here? We have 2, right? So this is the one we put a union because we're writing the interval notation. So this to this. So that is negative 5, comma, negative 5, comma this, which is the local max. And the x value is negative 3.75. Okay, and then union. And then this part is also increasing, right, from here to here. So that is the local min, which is the x value is negative 1. Yes, negative 1. And then to infinity. Yes. So negative 1 to infinity. And then the decrease, how many decreasing parts do we have? We also have 2, right? This to this is decreasing. So that is negative infinity up to this, negative 5. And then union Union, okay, yes. This is the x value of the max, which is negative 3.75, and then going down, which is the x value of the min. Yes. So that is negative 3.75, comma, negative 1. Okay? And then the domain will be all real numbers. But then the range is what? Okay, so the range, we don't have an arrow that's going to go down infinitely, right? So the range is not going to be all real numbers. So according to Leela, this is where we stopped at the bottom. And we're only writing the y value, not the x, because we're writing the range. What is the y value of this? Negative 32. So that is going to be including negative 32. So bracket, negative 32, comma, infinity. Parentheses. Okay, and we're done.